Hey everybody, Brian here. I want to talk about reliability analysis in SPSS using Cronbach Alpha. So here is a data file that I've downloaded from Qualtrics, and let's focus on these 10 items, a single matrix table with 10 questions. And I've already created subscales in a different video, combining the first 5 items into one subscale, and then the second 5 items, items 6 through 10, into a second subscale. And so those subscale calculations are shown as these two variables. Notice also for my first subscale, I had to account for some reverse scored items, 1, 2, and 3. I reverse scored before I calculated this average. So we want to make sure that we're using those reverse scored items when we do our reliability test as well. The idea of a reliability test is just to make sure that when we are combining items, that people's responses on the items that we're combining sort of are tending in the same direction, that they're similar enough that it makes sense to treat those items as a single measure, and that people's responses aren't just all over the map. So we're going to do pretty much what we did to create the subscale, but with a different part of the SPSS software. So instead we go to Analyze, we choose Scale and Reliability Analysis here. I'm going to find those. We'll start with the first 1 through 5. So I'm going to make sure I include my reverse scored items here. I can Shift and click to select more than one item in the list and bring those over to get the reverse scored items. And then I'll come over, if I right click in this list of variables and choose display variable names, it'll be easier to find through 4 and 5 from my original measure. The model is already looking at Cronbach Alpha, so I don't need to change that. But sometimes it can be useful if you're doing this more than once to provide a scale label. So that'll just appear in the SPSS output. So a good reminder of which analysis we're looking at. So when I choose OK here, it's going to pop up Cronbach Alpha. This is a terrible example. Normally you want a Cronbach Alpha that is a positive value, ideally higher than like 0.7, 0.8 is considered a pretty good Cronbach Alpha. I am using just totally fictional data, so having a negative response here is not what you are looking for. A lot of times you'll get a negative value if you forget to reverse score or something like that. So it's possible to get a negative value, but that's a huge red flag that something is going astray here. But this is basically what we're looking for. Here's that label that we put in. It's making sure it tells us how many people's responses we are including, how many items were combined. We combined 5 different questions, and then here's the alpha value. Let's go ahead and do this for our second set of variables just to see. I doubt it's going to be any better because that's also fictional data. But we can just go in here, reset that, find our second set of values, 6 through 10, bring all those over at once. I'll call this second half and choose OK. And oh yeah, that's not a great alpha value, but at least it's not a negative alpha value. So a little bit more plausible. And again, we have our label that we put in here. So you should do this whenever you're combining multiple items into a subscale. And it's traditional in APA style to report your alpha values just to demonstrate to your reader that you have done a reliability check and it makes sense to combine these questions into a single scale. So I wanted to show you that and keep it short. And so that's all I have. And let me know if you have any questions.